If we go to the worksheet, we see that a circle is a set of all points that are equidistant from a fixed point called the center. And in the case that we just showed, that was the origin. The distance from any point of the circle to the center is called the radius. The equation of the circle with center 0, 0 and radius r is given by x squared plus y squared equals r squared. And so now all we have to do is just use that formula to find different equations of circles. So for example 1, find the equation of a circle with center 0, 0 and radius, well here's radius of 5, so all we have to do is substitute that radius of 5 in for r there. So the equation would be x squared plus y squared equals 5 squared. And that can simplify to x squared plus y squared equals 25. If we go to part B, again, same formula. X squared plus y squared equals radius squared. Well, the radius is 3/4. We put that in for the r, we substitute 3/4 squared, and then we simplify, so we get x squared plus y squared equals 9/16. And then we move on to the radius of 0.5. Again, the same formula, x squared plus y squared equals r squared. In this case, r is 0.5. And then we can just simplify that, so we get x squared plus y squared equals 0.25. Alright, let's move along to example number 2. For this graph, right here, state the x and y intercepts of the circle. Well, if we just look at it here, x-intercepts, we've got 3 units on either side. So the x-intercepts would be, the x-intercepts are 3, 0 and negative 3, 0. We'll also write them as coordinates. And the y-intercepts then, again, will count from the origin. And so the y-intercepts would be 0, 3 and 0, negative 3. So notice that the x-intercepts and the y-intercepts are all 3 units away from the origin. Therefore, what would the radius be? Radius is 3. And then we write the equation. Well, the equation is in this form. We know the radius, so we can just substitute in just like we did in the first example here. So, the equation of this circle would be x squared plus y squared equals 3 squared. Therefore, x squared plus y squared equals 9. Okay, let's move on to example 3. Here's an equation now. X squared plus y squared equals 81. What's the radius? Well, when you look at the formula is x squared plus y squared equals r squared. That's the only thing that's different here, so we know that r squared equals 81. And if we take the square root of both sides, we see r equals 9. Now usually when you take the square root, you would take the square root of, you could get the plus or minus. But the radius is only a positive quantity, only a positive value. So it doesn't make sense to do our radius equals negative 9. We're just counting the distance from the origin. So the distance from the origin, anywhere around the origin, the distance is going to be 9 units. Okay, so we can just state that as a positive value, r equals 9. We want to find the x and y-intercepts. Well, if the radius is 9 centimeters, or 9 units, what would the x and y-intercepts be? Okay, so let's... the x-intercepts, the y-intercepts. Well, the radius is 9, obviously it's going to be 9 units from the center. So we'll just count it here, 1, 2, 3, 4, 5, 6, 7, 8, 9. Same thing the other side. Up the y-axis. And down on the negative y-axis. So the x-intercepts would be 9, 0, and negative 9, 0. And the y-intercepts would be 0, 9, and 0, negative 9. So now I need to graph this, or I need to sketch this graph. Being that I'm not an artist, this is not going to turn out very pretty. But if you can, better than I, try to sketch a circle here. I think I'll leave that to your imagination so I don't embarrass myself. So just use the power of your imagination to imagine me drawing a perfectly formed circle through these x and y intercepts equidistant from the origin. Okay, so now let's look at example 4. We want to know, is the point negative 3, negative 6 inside the circle with equation x squared plus y squared equals 49? Well, that's very interesting. What is the, let's take a look at the general formula of the equation of the circle, and we know that it is x squared plus y squared equals r squared. So that means that r squared equals 49. And if we try to find the radius, r equals the square root of 49. So if we take a look at this point, what we want to do now is we want to see how far this point is from the origin, because we know that the circle is centered at the origin and the distance from the origin is root 49, or also known as 7. So the distance from the origin to the circumference of the circle is 7 units, or root 49. So we want to know, where is this? Is this point outside or further than 7 units from the origin? Or is this going to be inside the circle, which would be less than the radius of this circle? Okay, so let's take a look at this. So what we need to do is we need to actually set up the, well, it's Pythagorean theorem, but it's also the formula for the equation of a circle. We've got our x value, we've got our y. We can work this out and we can see if our r squared is less than or greater than 49. Okay, so let's take a look at that. So negative 3 squared, negative 6 squared equals r squared. We square both of these. So we get 9 plus 36 equals r squared. We add those together, 45 equals r squared. So, because the radius, or the distance from the origin to this point, is the square root of 45, basically, because we take the square root of both sides of this, we get r equals root 45. Because that value of the radius that would be formed if we swung this around the origin is less than the root of the radius, or actually what the radius is, that tells us, because this is less than that this point is indeed inside the circle. And let's take a look here, a little bit of a real life situation, especially if you live in the Tierra del Fuego, or the Pacific Rim, where there's lots of earthquakes and lots of plate tectonics moving around and forming all kinds of tremors, etc. Earthquake sends out a circular shock wave. So that's the thing when they call it an epicenter. The shock waves kind of get expanded out in a circular fashion from the center, wherever that the plates slip and cause the quake. The radius increases by 6 kilometers per second. And we want to find the equation of the circle 25 seconds after the quake strikes. Well, we're talking about speed here, and we're talking about time. So that, and radius, of course, is distance. So hopefully, what would spring to mind would be that super handy distance, speed, time triangle that you know and love so well. So if we want to find the radius after a certain amount of time, we know the speed, we know the time, we need the distance. If we cover up distance, which is the one we need, we see that we would need to multiply the speed times the time. Okay, so after 25 seconds, how far has the shock wave, or the quake wave, expanded from the center? So the distance is the speed times time, and so that gives us 6 kilometers per second multiplied by 25 seconds. 6 times 25 gives us 150, and then we've got kilometers per second multiplied by seconds. This second here from the time is seconds over 1. We see now that we've got kilometer seconds divided by seconds. The seconds form a 1, so we're left with 150 kilometers, which is the distance from the center to the, or what they call the epicenter, out to the equation of the circle formed by the quake radius. And so then all we have to do is use this as the radius and the equation of the circle. So the equation of the circle would be, well, that would be x squared plus y squared equals 150 squared. Therefore x squared plus y squared equals 22,500. So that is the end of that. Here are some questions I would like you to do over the next evening. So please finish these up, and we will take a look at them the next school day. And thanks for watching, and we'll see you in class.